Okay, so what we're working on today is the one-dimensional motion worksheet number 2. Okay, so start from the top here. A poorly tuned geometro can accelerate from rest to a speed of 28 meters per second in 20 seconds. So again, what you want to do on all these problems here is, again, visualize what's going on. All right, draw a picture, label your frame of reference, okay, then pick out what you know, what are you looking for, pick an equation and go from there. So you want to be working with your equation sheet, and you'll be on the page 2 of your equation sheet and go from there, okay? So, let's see here. Geometry, so we'll draw a car. I'll say this way is positive, that way is negative. It says accelerates from rest, so I know my velocity initial here is 0 to a speed of 28 meters per second, so it's going this way. So at this point, velocity final is 28 meters per second in 20 seconds. Okay. So it asks, what is the average acceleration for the car? So I list my variables. VI is 0, T is 20, VF is 28. I'm looking for acceleration. You look at your equation sheet, okay, under kinematic equations. And what you want to do is go down and find an equation that has those 4 variables in it and those 4 variables only. Okay, if you go down and look at your equation sheet, it should be this one here. VF equals VI plus AT. All right, I plug in. VF is 28. VI is 0, so it cancels out. A is what you're looking for, and time is 20. To solve, divide by 20. A is equal to 1.4 meters per second squared. Okay? B. Now it asks, what distance does it travel in a time? If you're looking for distance, you're looking for delta x. Now, you know all of these variables. You even know A now. So if you know all of them, you can use basically any equation that has delta x in it. So what I'm going to do is I'm actually going to pick an equation that's already solved for delta x. So I'm going to use this one here. I'll use delta x, VIT plus 1/2 AT squared. So again, I use the same variables here. I'm looking for delta x. VI is 0, so 0 times anything is 0, so that cancels out. I have 1/2. A I found to be 1.4, and I have 20 squared. Solve. So my calculator, I would start by doing 20 squared is 400 times 1.4 times 0.5. I get 280 meters. So in that time, it travels 280 meters. Pretty easy, pretty straightforward question there. Again, take the necessary steps, keep your information organized. Okay? Good. All right, so next problem says, at t equals 0, a car has a speed of 30 meters per second, and t equals 6, a speed of 14 meters per second. What's its average acceleration during this time interval? Okay, so the change in time, so time that goes by, is 6 seconds. Okay, it has a speed of 30 meters per second, so VI is 30, and VF is 14. Find the acceleration. Okay, so if you see here, it's starting at 30 and ending up at 14 meters per second, so it's slowing down. You have positive velocity, so to slow down a positive velocity, you need a negative acceleration. So you should expect to get a negative acceleration here. Okay? Just go ahead and look. Look at your equation sheet. You have these 4 variables. What equation only has these 4 variables? Oh, it's this one right here. VF equals VI plus AT. I plug in and solve. VF is 14, VI is 30, plus AT is 6. Solve. Subtract 30. You get what? Negative 16 divided by 6. A equals negative 2.67 meters per second squared. Again, nice and easy problem here. Just getting used to the format. Okay, so we're going to keep moving on here. Number 3. All right, number 3 says, a bear spies some honey and takes off from rest, accelerating at a rate of 2 meters per second squared. If the honey is 16 meters away, how fast would his snout be going when he reaches the treat? Okay, so you get a bear running. It starts from rest, so right away you know VI is 0. Starts from rest, VI is 0. It's accelerating at a rate of 2 meters per second squared, so A is equal to 2 meters per second squared. All right. The honey is 16 meters away, so if it's meters in distance, it's 16 meters is delta x. You're looking for VF. How fast will he be going when he gets to the end of the 16 meters? Again, look at your equation sheet. Which equation only has these 4 in it? Give me a second. All right. VF squared equals VI squared plus 2A delta x. I have all 4 of those variables in there. I can solve. VF is what I'm looking for. VI is 0. That cancels out. I get 2, 2, 16. Solve. VF equals, VF squared, sorry. VF squared equals 2 times 2 times 16. 64. To solve, I square root both sides. I get VF is equal to 8. 8 meters per second. Okay, good. Number 4. Number 4 says, a bus moving at 20 meters per second slows at a rate of 4 meters per second each second. It asks, A, how long does it take for the bus to stop? So 4A. So if you're asking for how long does it take for the bus to stop, we know that its final velocity must be 0. So VF equals 0. Okay? We know that, let me draw a picture in this case. So you got a bus moving down the road. Okay? It's traveling at 20 meters per second, so VI is 20. So if it's traveling this way, and I've set that to be positive, that means this way is positive, this way is negative. If you're coming to a rest, you're slowing down. And to slow down a positive velocity, you need a negative acceleration. Even though it gives you the acceleration as positive, we have to draw this picture and say, oh, to slow down 20, we would need a negative 4 meters per second squared. So I write it here, I go, acceleration is negative 4 meters per second squared. My velocity initial is 20 meters per second. And the problem in A asks me to find how long, in other words, time. I look at the variables. Which equation can I use? I can use this one. VF equals VI plus AT. VF is 0, VI is 20, plus negative 4t. Subtract 20. Cancels out. I get negative 20 equals negative 4t. Divided by negative 4. Cancels out. Negative 4t equals, what is that, 5 seconds. B says, given the same information, how far does it take to stop? So how far is delta x? Again, I can use all the variables here. okay, I might use this one. I might go delta x equals v, what is it, vf plus vi divided by 2 times t. Delta x, vf is 20 plus 0 is that divided by 2 times t, which is 5 seconds. Delta x equals 50 meters. All right, pretty straightforward here. Pretty easy problems. There's no like tricks or double steps or anything like that. It's just straightforward so far. Get used to using the equations and everything like that. All right, let's move on to number 5. Number 5. A physics student skis down a hill, accelerating a constant 2 meters per second. If it takes her 15 seconds to reach the bottom, what length is the slope? So we'll assume that at the top of the hill, you start from rest, right? You're getting ready to go over it, you go over. So VI equals 0. Okay? Accelerating at 2 meters per second squared, A. And 15 seconds. Reach the bottom of the hill. T equals 15 seconds. It asks, what is the length of the slope? In other words, how far, which is delta x. Here's our values. We need to figure out which equation. Look at your equation sheet. Which one has all 4 in there? Oh, it's this one. Delta x equals VIT plus 1/2 AT squared. Delta x equals VI0, cancels that out. 1/2 A 15 squared. That you can just do. So in your calculator, you kind of just do 15 squared times 2 times 0.5, so 225. 225 meters is the length of that slope. Again, straightforward here, nothing tricky here. All right. Six. It says, a dog runs down his driveway with an initial speed of 5 meters per second for 8 seconds, then uniformly increases his speed to 10 meters per second in 5 seconds. All right, what was his acceleration during the second part of the motion, and B, how long is the driveway? All right, so this is a 2-part problem. Anytime you have a change in acceleration, so in the beginning of the part, the dog is running at a constant 5 meters per second. Then he speeds up to 10 after the first 8 seconds. So I'm going to draw this. Again, I'm a very good drawer, so this should be a very realistic picture. So this is going to be a dog. Dog. All right? It runs this way. It takes 8 seconds, and it runs at an average speed of 5 meters per second because its velocity doesn't change in that first 8 seconds. He stays at 5 meters per second for that first 8 seconds. So really, his acceleration at this point is 0, but we don't really need it, but we know it's 0. Then he starts speeding up for the last, the last 5 seconds, right? So over here, the time is equal to 5 seconds. He starts at, VI is 5 meters per second, and speeds up to 10 meters per second. So he ends at VF is 10 meters per second. All right? So we have the drawing. He's holding speed. Oh, he reaches this point after the 8 seconds, he speeds up. So we're going to break it in part 1 and part 2. So A asks, what was his acceleration in the second part? So part 2. We have VI is 5. We have VF is 10. We have time is 5. Looking for acceleration. Look at these 4 variables. Which equation am I using? I'm going to use this one. VF equals VI plus AT. VF is 10. VI is 5 plus AT is 5. Subtract 5, I get 5 equals A5 divided by 5, I get acceleration is equal to 1 meter per second squared. That's for A. B asks, how long is the driveway? So we got to break this up. We got to find the distance in part 1 and in part 2. So for part 1, it's pretty easy. Part 1. I know that my average velocity is 5 meters per second. I know my time is 8 seconds. All right? I'm looking for delta x. So I can use the definition of velocity, average velocity. Delta v equals delta x over t. Average velocity equals delta x over t. I plug in 5 equals delta x times 8. So I multiply by 8. I get delta x equals 40 meters. That's how far he covers in this first part, not the entire time. Okay? So we have to find part 2. We've already listed the variables for part 2 here. Now all we have to do is find delta x. So if I just use any equation here, I can go delta x equals Vf plus Vi over 2 times t. I plug in delta x equals Vf is 10 plus 5 over 2 times time, which is 5 seconds. So in the calculator, what I would do is I would go 15 divided by 2 times 5. And I would get 37.5 meters. Now, your final answer, total distance, is 40 plus 37.5. So I get total is 77.5 meters. Okay, 77.5 meters. That one was a little bit more difficult. That's a 2-step problem there. You got to just remember, anytime you change acceleration, you have to break it up. You cannot go through that change of acceleration. Okay? Let's do number 7. Switch colors and markers down here. Number 7. It says, a mountain goat starts a rock slide and the rocks crash down the slope 100 meters. If the rocks reach the bottom in 5 seconds, what's their acceleration? Well, obviously the rocks are at rest, right? So Vi is 0. It falls a distance of, or it slides down the slope at 100 meters. So delta x distance is 100 meters. What else? And time is 5. Yes, time is 5 seconds. T is, what's the acceleration? Look at your equation here. I can do this one. Delta x equals VIT plus 1/2 AT squared. Vi is 0, so I'm solving for this. I got 100 equals 0, so that cancels out. 1/2 A 5 squared. Solve. I can just do 25 times 1/2. What is it? 12.5. 25 times 0.5 is 12.5, so I get 100. Divide by 12.5. A equals 100 divided by 12.5 is 8 meters per second squared. Okay? Again, another straightforward, easy problem. This one shouldn't have been that hard. Okay. In coming to a stop, this is number 9. Oh, wait. Oh, 8, sorry. Number 8. Number 8. It says, a speedboat starts from rest and accelerates at 2.01 meters per second squared for 7 seconds. At the end of this time, the boat continues for additional 6 seconds with an acceleration of 0.518 meters per second squared. Following this, the boat accelerates at negative 1.49 meters per second squared for 8 seconds. So as you notice, you have 3 changes of acceleration. So you're going to break this up into 3 parts. So I'll go ahead and start drawing this. Boom. All right. So it says in the first part here, it starts from rest. So I know at this point here, my VI is equal to 0. It accelerates at 2.01 at the beginning and a time of 7 seconds. That's all we know at that. So then it goes to the second part for a time of 6 seconds with an acceleration of 0.518. Then at the end it accelerates at negative 1.49 for a time of 8 seconds. So do you see how every time we change acceleration here, I have to break it up. It's its own separate problem. It's part 1, part 2, part 3. So it wants us for A to find the velocity at this point. So the strategy we have to use here is we have to find the velocity final here. Once we know the velocity final, that becomes the velocity initial for the second part. We calculate velocity final. That becomes velocity initial for the third part. Okay, so let's start. Part 1. We have acceleration is 2.01, VI is 0, T is 7, find VF. Look at your equations, or your variables. The equation you're going to use is this, VF equals VI plus AT. VF is what I'm looking for, VI is 0, goes away, A is 2.01, time is 7. VF. Calculate. $14.07. All right, let's look at part 2. So if it's traveling at 14.0 seconds or meters per second here, and it changes acceleration, that means it's just going to be the velocity initial for the second part. So my velocity final for the first part becomes my velocity initial for the second part. So VI for the second part is 14.07. I know acceleration is 0.518. I know time is 6 seconds. I'm looking for velocity final. So again, I'm going to use the same one. VF equals VI plus AT. VF is what I'm looking for. VI is 14.07 plus A 0.518. T 6 seconds. VF. All right, in your calculator here, you're going to do 0.518 times 6 plus 14.07 and get 17.18. Okay? Now, that's the velocity final for part 2. That becomes the velocity initial for part 3. VI is equal to 17.18. A is now negative 1.49. T is 8 seconds. And I'm looking for VF. So again, same exact equation. VF equals VI plus AT. VF is what I'm looking for. VI is 17.18 plus A is negative 1.49. T is 8 seconds. Solve for VF. To do that, I will do 8 times negative 1.49, which gives me negative 11.92, plus 17.18. I get 5.26 meters per second. There you go. All right, so that's our final velocity at this point there. Okay, so that's actually our final answer for A. Now, for part B, it says, find the total displacement for the boat. So what you have to do here is actually calculate delta x for each one and add it up. So again, I'm just looking for delta